This video is to demonstrate graphing secant and cosecant functions. For this example, I will use the graph of 2 secant of pi x. Our basic strategy as covered in class is to graph the reciprocal function that corresponds to this function as a guide. So the reciprocal of secant is cosine, so we'll graph as our guide function the 2 cosine of pi x. The only thing changing about the equation is the trig function named. To graph the 2 cosine of pi x, we have our period as 2 pi over b, where b in this example is the value pi, so we get 2 pi over pi, which is a period of 2. Then we want to build our table of x values with 5 rows, 1, 2, 3, 5, and we'll evaluate what x times pi is. And in that step, the middle column should result in values that we can take the cosine of that are right on one of our axes, whether that is 0 radians, pi over 2 radians, pi radians, or 3 pi over 2 radians. To determine the starting and ending values for our table, we set both bx plus c equal to 0 and equal to 2 pi. In the case where it is equal to 0, this bx plus c is just the value pi x. It's what we're taking the sine or cosine of. So solving for x in the case where it's equal to 0 results in 0 divided by pi, which is 0. So our table will start at 0. For the ending x value in our table, we're going to set that pi x equal to 2 pi, divide by pi on both sides, and we get the whole number 2, because we have 2 pi over pi. Then we fill in the rest of the x column by identifying the midpoint between the given values. So the third row will be halfway between 0 and 2, which is the value 1. And then row 2, we're going to have the x value halfway between 0 and 1, which is 1/2. And in row 4, halfway between 1 and 2, which is 3/2. If you need a review on how to find those midpoints without proportional reasoning, but with a formula way, you basically find the average of the 2 points by adding them together and dividing by 2. You can view the previous video about graphing sine and cosine functions if you need a further review. Now that the x values have been chosen, we need to fill in the next column in our table, which would be that center column, which will identify what angle we're actually going to take the cosine of. Then we will multiply 2 times the cosine of those angles to find our y values. So pi times 0 is 0. Pi times 1/2 is pi over 2. Pi times 1 is pi. Pi times 3/2 is 3 pi over 2. And pi times 2 is 2 pi. As mentioned in the previous video and in class lecture, this center column should result only in angles that fall right on an axis. So taking the cosine of the angles is as simple as identifying the x coordinate for that angle on a unit circle. So next, we fill in the last column of the table by taking the cosine of pi x and multiplying times 2. So the cosine of 0 is positive 1. 1 times 2 is 2. The cosine of pi over 2 is 0, because it's the x coordinate for that angle. So 0 times 2 is 0. The cosine of pi is negative 1. Negative 1 times 2 is negative 2. The cosine of 3 pi over 2 is the x coordinate for that point on the unit circle, which is 0, and 0 times 2 is 0. And then lastly, 2 pi. The cosine of 2 pi is 1. 1 times 2 is 2. So we have enough information to draw the guide functions graph. So I'm going to label my x-axis according to the x values in the table. So starting from 0, I'll indicate 1/2, 1, 3/2, 2, and if I needed more than one period of the function, I could extend my x-axis in either direction and simply repeat the pattern. The guide function is bound between a maximum value on the y's as positive 2 and a minimum value of negative 2. Because my aim is eventually to graph the secant function rather than the cosine, I am going to show my axis further up than positive 2 and further down than negative 2. And then we have our minimum, our maximum, and our center identified. We can begin to graph the 5 points represented in the table, the x coordinates being on the far left of the table and the y coordinates on the far right of the table. So the first point graphed is 0, 2, then 1/2, 0, then 1, negative 2, 3/2, 0, and 2, positive 2. And we have our cosine function that is our guide function. I'm going to draw in as a dotted curve because it is not our actual graph for secant. All of those first steps were just to graph the guide function. Now to graph the actual secant function. If where the guide function crosses the center line, so I have 2 locations where it crosses the center line in this period, that is where we have a vertical asymptote present. So wherever your guide function crosses the center line, you have vertical asymptotes. In between those vertical asymptotes, your guide function is either reaching a maximum value, in which case you should draw that U-shape curve opening up in between the asymptotes. So there are 2 maximum values shown in my period. So I have 2 U values, U shapes going up. And where you have a minimum, you will have a U shape coming down in between the asymptotes. It should not cross the asymptotes, and it should touch that same minimum or maximum point. So these methods can be used both for graphing secant and cosecant.